Here is the second part of the lesson 3 videos. So for this one, I'm just going to be doing 2 reaction stoichiometry problems. The first one, you can see we're given the reaction and it is balanced, and we just need to figure out how many moles of N2O are produced when you start with 52.0 grams of NH4NO3. So to do that, I'm going to use the same stoichiometry document that I used in lesson 1, but now we're going to go from A to B. So last time I said you don't need to worry about the A and B. Now you are. So A is going to be the substance that you start with, the substance that is in your given. So A, substance in given. B is the substance you're looking for. So when you read your problem, you're not only going to underline your given, you're also going to mark the substance in your given with an A. And then you're going to circle what you're looking for, and the substance in what you're looking for is going to be your B. So here, you're going to follow the same rules. Start with what you're given, write both parts of your units, put your given over 1. So our given is going to be 52.0 grams, and then the second part of our units is going to be that substance. So that's our first factor. Second one says use the unicorn diagram to determine the number of factors. So here in this problem, our given is grams of A. Okay, what we have is 52.0 grams of NH4NO3, so grams of A. We are ending at moles of B. So we're ending at moles of N2O in this problem. So we have to go from grams of A to moles of B. We start with grams of A. Grams of A is going to be our first factor. It's also our given. And there's only one place to go from there. If you remember, you have to follow the connected paths. Okay, so grams of A, the only place that we can go is then to moles of A. So grams of A, that's one factor. Then we go to moles of A, that's 2 factors. But that's not where we want to end. We want to end at moles of B. So the rainbow in this diagram is just like a fancy line. So it acts just like this line does. I just made it a rainbow to make it more interesting. So if we go from grams of A, we then go to moles of A. That's our second factor. And then we travel over the rainbow to moles of B. Okay, so just like we didn't count this line as a factor, we don't count the rainbow as a factor either. When people are first getting familiar with this diagram, sometimes they will. But you only count the units as factors. So grams of A is 1, moles of A is 2, moles of B is 3. So I'm going to have 3 factors for this problem. So now step number 3, drop down both parts of your units. Grams of NH4NO3. And then the unicorn diagram will tell you what goes on the top. It tells you the path you have to take. So your unit After we had grams of A on the top of our first factor, the next place we went was moles of A. So I'm going to write moles. And then instead of writing A, I'm going to write what A actually is, NH4NO3. And then the next step, step number 5, says to keep doing 3 and 4 until you have factors. So going back to 3, we're going to put moles of NH4NO3. And then the next place we went on our diagram is moles of B, which is N2O here. And then if you remember from the first video, this also works because whatever you're looking for needs to go on the top of the last factor. So if you've done everything else correctly, it should work out. So now we're going to solve this exactly like we solved it in the first week. You're going to plug in your numbers based on your units. So moles on top, grams on the bottom. We go to our conversion factor, moles on top, grams on the bottom. So we plug in 1 for moles, and then the molar mass here. Now, if you've labeled everything correctly, you know what molar mass goes here. It's going to be the molar mass of whatever substance you have. So here, NH4NO3. If you don't label it correctly, you might start to get confused at this point because there are 2 substances in the problem. So how are you supposed to know which one to do the molar mass of? And that's another reason it's really important to have both parts of your units all the time. That way you don't start to get confused here. So I'm going to find the molar mass of NH4NO3, and that is 80. So now for my last factor, I have moles on top and moles on the bottom. So that's this one right here. This is called the mole ratio. So we have moles of B on top and moles of A on the bottom. And you'll notice that the numbers we plug in there are coefficients. So what that means is the coefficients from the balanced equation. So if we go back to our problem, our balanced equation is right here. So what you do is you look up each substance. So for N2O, you look here. Whatever the coefficient in front of N2O is, you copy here. So it's going to be 1. And then you do the same thing for NH4NO3. This coefficient's also 1. So you're just going to put a 1 there. And then you solve that. And there's your answer. Okay, now that's a pretty basic stoichiometry problem. This is AP, so they're not going to be that basic and easy for the most part. This is more representative of something you might see. Here, you are given the reaction in words. You have to write the chemical equation, make sure it's balanced, and then solve the problem. Okay? Now, I mentioned in part 1 of lesson 3 that balancing needs to become something that that's second nature to you, that you do very quickly. Naming also needs to be that. Okay? Writing chemical formulas or converting from a chemical formula to a name, that is something that you just need to practice until it is very, very quick for you. Okay? If you are not at that level yet, which I assume most people are not, or at least need a refresher, I am going to post my naming compounds quick guide on your classroom with this assignment, okay? So in here are the basics for naming. So I have the ionic compounds broken up into their 3 main categories: covalent compounds, You will see on this that acids are not included. Some people have exposure to naming acids and some people do not. So when we get to our acid base unit this year, we're going to just go over that together, okay? You will also notice that the polyatomic ion list is much shorter because this was for honors chemistry and you are now in AP chemistry, okay? So the ions that you need to have memorized are posted on your classroom. So if you go there, there is something that says polyatomic ions to memorize. You need to have all of those memorized, and I tried to break it up into groups to help you with that. Okay, so make sure you are also memorizing those, because again, this naming stuff needs to be so quick so that you can concentrate on the more difficult things. So, sodium phosphate is Na3PO4, and then I'm going to add it to potassium hydroxide. They react to form sodium hydroxide and potassium phosphate. So I'm going to do just real quick, do the naming part for sodium phosphate. I'm not going to do it for all 4 of the compounds because you can look at the quick guide. So basically, to write the formula for sodium phosphate, I looked up sodium on the periodic table, and I saw that it gets a 1+ charge because it's in group 1A. Phosphate, I have memorized, is PO4 3-. I then crisscrossed and got Na3PO4. Okay, so that's how I wrote all of these formulas. Now I need to make sure my equation is balanced. Right now it is not. So I'm going to put a 3 here and a 3 here. And now it is balanced. Okay, now you need to make sure these are balanced because in the mole ratio we use those coefficients. So you need to make sure you have the right ones. All right, now that we've done all of that, we can actually solve our stoichiometry problem. So we have 4.50 grams of potassium hydroxide, and potassium hydroxide is our A. We are looking for grams of sodium hydroxide, which is going to be our B. So we start with 4.5 grams of potassium hydroxide. We then go to our unicorn diagram to figure out how many factors we need here. So we're going from grams of A to grams of B this time. So grams of A, that's 1 factor. Moles of A, that's 2 factors. And then moles of A is not connected to grams of B. There's no line connecting them. So you have to go through moles of B, and then you can go to grams of B. Okay? So those are going to be our 4 factors. Grams of A, moles of A, moles of B, grams of B. So we're going to need 4 factors. We then drop down our units. We use the unicorn diagram to figure out where we go next. So if we're at grams of A, we then go to moles of A. In this problem, that's moles of potassium hydroxide. We drop that down. And on our unicorn diagram, the next place we went was moles of B. Drop that down. And we end up at grams of NaOH. So now you can plug in your numbers based on your conversion factors. So when we have moles over grams, we have a 1 with moles, and our molar mass of KOH is 56.1. Now here we need the coefficients for NaOH and KOH. So NaOH's coefficient is a 3, and so is KOH's, it's a 3. And then here we have 1 with moles and 40 with grams of NaOH. And when we do that out, we get 3.21 grams of NaOH. So again, for this assignment, I'm going to post these 2 videos, the notes handout, and I'm also going to post 3 quick guides. The balancing, I'll post the stoichiometry one again, and the naming one. Okay, the reason I'm posting these are from Honors Chem. The reason I'm posting them is to help you review the stuff that you learned in your prior chem class. If you have any questions on this video, I will have a Google Meet, not the 19th, because I have AP training then. So the Google Meet for lesson 3 will be on the 26th.